What up, Rother fam? We're back with another banger video, this time talking about reactivity and how the elements make their way to becoming most like a noble gas. So let's title these notes today, Reactivity, Reactivity is the way something reacts. And in chemistry, we're talking about how they react chemically. So on this paper, if you will, on the top half of this journal page, we're going to sketch a periodic table. And on the bottom half, we're going to draw two Bohr models. So let's get the top half. So let's draw the line to divide our top and bottom halves. And then on this top part, we're going to sketch the periodic table. We're going to draw the left side of the periodic table. We will draw the bottom of the periodic table. And then we'll draw the right side. Now let's get the groups done. So we're going to go over just a space, and then we'll go down a space, and then we'll go over a space, and I'm going down about 2 spaces, 2 elements worth. And then we're going to skip over, these are called the transition metals. And I'm going to shorten it just a little bit. So these elements in here we call the transition metals. So we're going to go up to meet here. We'll go over right to where we hit the noble gases, come up and over. And you've just sketched your 3rd periodic table of the year. All right. Hydrogen over here is the head of the family we call the the family or the group that's called the alkali metals. These guys right here are going to be very reactive. These guys will be very reactive, exclamation point, exclamation. Okay, so this group right here has a roof over its head because they all behave similarly. We have a bunch of different elements, but they behave similarly because this group has one valence electron. So this group, hydrogen's family, has one valence electron. We could look at the periodic table to see the name of this family. We do know every element under here, whether we know their names or not. Every element in this group right here has 2, V for valence and E negative for electron. This group and all of its elements inside are going to be somewhat, so I'm going to put somewhat reactive. Okay, now all these elements are also going to react. They're going to form bonds to try to be as much like a noble gas as possible. So let's scoot over to the noble gases. Instead of a rooftop, we're going to put a castle. These guys are like royalty. They will have nothing to do with the other elements on the periodic table. The other elements are like peons. And so that castle is headed by helium. And then I believe under helium is neon. And I believe we have, I think it's argon, krypton. Do we have to memorize that? No. We just need to be able to look at a periodic table. Mine is not glued in here. We need to look at a periodic table and we can figure it out. All right, these guys are called the noble gases because they never react. They are called, so the noble gases are what we call stable. The noble gases are considered to be stable. All right, this group right here is 7A. This is 7A, and I believe the head of this group or family is fluorine. Fluorine and all the other elements below it have 7, V for valence, E negative for electrons. They have a name called the halogens, but the only thing we really need to know is that they are very reactive. All right, these guys are very reactive. They have 7 valence electrons and they need 1 more. So they're gonna likely kidnap from the elements in group 1, or they will kidnap an electron from these elements. They'll form a bond to be more like a noble gas. All right, we're gonna draw 2 Bohr models down here. We're gonna kind of show what that would look like on a Bohr model. We're gonna put 2 elements boxes. In the first elements box, we're going to put the number 3. If we looked on the periodic table, the identity of that will be lithium. And the mass of lithium is 7. Now we can draw a Bohr model of lithium. Take the numbers we have here, and we have a nucleus with 3 protons. The mass is 7. So we know 3 of those are protons. What number would we need to put right here?
4.
Thank you. We would put 4. Now for every proton, we need an electron. So we need to draw 3 electrons. So we're gonna go, there's 1. How many will fit?
2.
Nice, 2. All right, we can't squeeze a third one in, so we're going to make a second energy level. And we're gonna put, it's 1 lonely valence electron there. Now, by looking at this Bohr model, we see that lithium has 1, 2 energy levels, right? So lithium should be on period 2, is it? Well, it sure is. Now, having this 1 valence electron, it should be in group 1. Is lithium in group 1? Well, it sure is. Okay. Let's scoot over here, and we're gonna do one called, I think it's fluorine. Okay, we're gonna do, well, I've lost my place. Yes? We're doing okay? On time? Okay, here we go. Yeah, we are gonna do 9, okay, 9, F, and 19. All right, 9, F, and 19. We do a Bohr model real fast. All right, if we have 9 protons, how many neutrons will that make us? What number do we need here? We need 10. Okay, so 9 protons. We can put 2 in here. That's our first energy level. And we have to make a second one. And we need 7 more. So on our second energy level, we're going to put 2, 4, 6, and 7 right here. How many more electrons does fluorine need to have 8, like a noble gas? It needs just 1 more. Now let's look at fluorine. Fluorine is over here. Does fluorine have 7 valence electrons? It does, doesn't it? Okay, does it have 2 energy levels? And it's on period 2. So the periodic table don't lie. So here's what nature's gonna do. This fluorine and this lithium are gonna say, dude, let's share an electron, and together we will have a full outer shell. And so it's going to create a compound called lithium fluoride. Because this electron will scoot over here and fill up that space, and they'll say together we'll lock arms, share these 2 electrons, and we will form a bond. Thank you so much, 8th period. You did a banger of a job watching that video.